Hello mga kabulero, we are done with the image processing techniques. Now we are moving on to the next section of our discussion, which is the image analysis techniques. Let's begin with image segmentation. So image segmentation focuses on partitioning an image into different parts according to their features and properties. The primary goal of image segmentation is to simplify the image for easier analysis. And in image segmentation, you divide an image into various parts that have similar attributes. And the parts which you divide the image are called the image objects. So I have prepared two sample segmentation techniques, which are the global thresholding and the morphological segmentation. So let's get started. So thresholding is a type of image segmentation where we change the pixels of an image to make the image easier to analyze. And in thresholding, we convert an image from color to grayscale and then into a binary image, meaning one that is simply black and white. So for global thresholding, our first example, we have here a threshold represented by T, and that is a constant, and it is applicable to the whole image. So the initial estimate of the threshold is generated after the RGB image is converted to grayscale and then adjusted through contrast stretching. So what happens is each pixel is compared to the threshold value. So if the individual pixel is greater than T, it will be considered as 1 or white. And then if the pixel value is less than or equal to T, the output value after thresholding will be 0 or black. And that is why we can get a binary picture or a binary image with only simply black and white. So thresholding is one of the most commonly used segmentation technique to inspect the properties of an image for image detection and classification. So here is an example of the global thresholding using a simple function IM_binarize. And in the previous versions of MATLAB, the function can be written as IM2BW. So during execution, it's still applicable, but a recommendation is showing to use more intuitive type of code for binarizing images. And by the way, before doing the binarization, convert the image to grayscale first, and then apply the automated contrast stretching function, which is the IM_adjust, and this was our topic from the previous video, right? Notice that some additional elements on the code, such as adaptive, foreground polarity, and dark, and these codes convert the image into binary image using the adaptive thresholding, and use the foreground polarity parameter to indicate the foreground is darker than the background. So let's go ahead and check the program in MATLAB and see how it works for a different example. So we have the IM_read, IM_to_gray to convert it to binary or to grayscale, IM_adjust as the contrast stretch formula, and then here the IM_binarize, the most intuitive function for converting it to binary image, and then use the adaptive, foreground polarity, and dark as what we have mentioned on our discussion. So let's run this code and see how it looks like. And this is how the binarization works. So you have a color image, and then you convert it to grayscale image, and then binarize. And look at the resulting image. It's now simply a black and white version of the original image. And this will be processed to classify and to analyze the images on several examples and applications in image detection and classification. All right, so we are done with the global thresholding technique. We now move on to the next example or the next process of image segmentation. Now, we have the mathematical morphology or the morphological segmentation. It's also known as the structuring element. So, a structuring element is a shape used to probe or interact with a given image. And with the purpose of drawing conclusion on how this shape fits or misses the shape in the image, we have two types of morphological segmentation to discuss. And these are erosion and dilation. And we will be discussing this using an animation to be able to illustrate how erosion and dilation differs from each other. So we will be discussing first erosion, and this is how the erosion works in an image. So the output of erosion is always a subset of the original image. The operation for erosion is synonymous to subtraction. So since we are applying subtraction, what we expect from our original image is a thinner version of the binarized image. And later on, we will be discussing dilation. And let's compare the output image of a dilation versus an erosion. So in the following example, we will be using the same structuring element, which is a 3 by 3 matrix with the values 0, 1, 0, 1, 1, 1, and 0, 1, 0, as you can see on the picture with the orange or the amber color. So the original image looks like on the left-hand side, which composed of two zeros on top, at the middle, and then two zeros at the bottom. So let's proceed with the animation. So let's see how it works for this quick animation. And for erosion, by the way, the structuring element finds the portion of the image where it fits its dimension through convolution. So we've learned about convolution previously. It's multiplication and then doing the average. All right. And then, I'm sorry, doing multiplication. I'm sorry, I introduced the average. That's for average or mean filter, right? And then all the areas where the center of the structuring element that lands to a 1 will be retained as 1, else they will be converted to 0, right? So this is how it goes. So in summary, erosion removes thin lines, isolated dots, and leaves gross details. And it also peels away layers. So it looks like a filter, right? An average or a mean filter, but it does have a different structure or a different matrix. And that's what we call the structuring element. And later on, I will show you a great example to better appreciate the purpose of erosion function. But before that, let me discuss the next structuring element method, which is dilation. And we will be discussing it, the output side by side, so that we can compare further how the erosion and the dilation fits to a picture. Okay? So in dilation, it is the exact opposite of erosion. And if erosion makes the outlines for or makes thin outlines, for dilation, it fattens up. And then let's now evaluate the output image pixel after applying dilation. And we will notice that we are still using the same values for the structuring element for comparison. So for dilation, all the 1 values of the structuring element will be plotted to the output image. The operation used for dilation is synonymous to addition. That's why it's exact opposite of the erosion. So that is why the output of the image is thicker than the ordinary binary image. Now let's try to visualize the convolution process using a simple animation. So in summary, dilation is the exact opposite of erosion. And notice that the original image is a 2 by 7 matrix and the output image becomes 4 by 9. So meaning it adds up the components of the original grayscale image and the kernel or the structuring element. So to appreciate its purpose, let's evaluate the algorithm using MATLAB. So we have here the erosion function or the erosion codes. I am read. Figure is just to show you the original image. The example here is the Iron Man picture at the bottom left. And then IMGS is the grayscale conversion. IM to BW is the binary conversion. And we use the strel or the structuring element, and it's a disk. And the area is 1. All right, and that's the same function that we'll be using or the structuring element for the dilation. And in here, let's say this is still this is still 1. And here, the function for erosion is I am erode, and in the dilation, I am dilate. So let's show the resulting image after the erosion and dilation. All right, so here is our original image. This is after erosion, and this is after dilation. So look at the difference. The binary image for erosion has more white components versus the dilation, because in for dilation the black portion of the binary image thickens. For erosion it is thinner, right? And that's how the erosion and dilation looks like. We'll be showing you some applications or examples of dilation and erosion at the same time, so that it is used tremendously in um, image classification and image analysis. So let's go back to the presentation to show you more examples and application. So we have the morphological operations involving erosion and dilation. And these are what we call opening and closing. And this methods uses both erosion and dilation, but the main difference is the order using the type of Strel function. And we will be first discussing opening. And opening process begins with erosion and then afterwards dilation. So its purpose is to break narrow bridges and eliminate thin structures. So if our objective is to remove the hair-like elements, this one, hair-like elements on our original image, opening operation is very helpful. Moreover, we will notice a great outline of the ripe pili fruit after using opening. So this is the code, IMGS, IMBW, Strel. We use the area 3 for our structuring element or disk element. Now we have IM open, and it removed the hair-like structures or hair-like elements on our original image, and the output image is a more structured output image. And lastly, for our closing, of course, it's the exact opposite of opening. For closing, notice that the hair-like element on the image were thickened. Therefore, to eliminate these unnecessary elements, closing is not the right option. So closing begins with dilation. Again, for dilation, you thickens the original image or any thin images, it becomes thick, right? So its purpose is to fuse narrow breaks and then eliminate holes. So in our previous example, we have thicker holes in here, and look at this one. It almost removed, or the edge is removed from the output image. But here, look at this, it still has that edge of the original image, right? So this is the applications, or these are the applications of morphological segmentation using the structuring element. We have erosion, dilation, and we have the applications for closing and opening. So this is the end of the image segmentation topic. I hope you enjoyed this presentation. And by the way, we use these techniques to come up with the real-time pili sorting project, which we will be showing you on our upcoming videos. Thank you for watching.